Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. If limit n tends to infinity, square root of n square minus n minus 1 plus n alpha plus beta equals 0, then find the value of 8 times alpha plus beta, right? So this is a problem which appeared in one of the IIT JEE exams, and I thought it's a quite an interesting problem to pick up and solve. So what we have been given is that we have an expression in terms of n, and as n tends to infinity, the expression tends to a finite limit, right? So let's write down what the expression has been given to us. So there we have the expression given to us: limit n tends to infinity, square root of n square minus n minus 1 plus n alpha plus beta. And whenever we have been given an expression of this type which has a square root term, and the term inside the square root is n square minus n minus 1. The term outside the square root is n alpha beta being constants, and that's what we've been asked to find. We have been asked to figure out what is alpha plus beta. The best way to proceed in this problem is to rationalize the expression, right? So let's do the rationalization and see what we end up in. And what does your rationalization mean? Your rationalization means that expression square root of n square minus n minus 1 plus n alpha plus beta, we multiply and divide by square root of n square minus n minus 1 minus of n alpha plus beta, and divide by square root of n square minus n minus 1 minus of n alpha plus beta, right? So that way expression does not change, but I know that in the numerator I will be able to eliminate my square root, right? Why is that? Because the first part of the expression, let me highlight it in yellow, is of the format, let's say a plus b. Then the second part of the numerator, again highlighting that in yellow, is of the format a minus b. So what's an a plus b into a minus b? It's nothing but a square minus b square, right? So what happens in the subsequent step is I don't disturb the denominator, but I apply the formula a plus b into a minus b equals a square minus b square to rewrite the numerator as follows. So that's my numerator. Now you can see that my a square minus b square term in the numerator is nothing but square root of n square minus n minus 1 the whole square minus n alpha plus beta the whole square, right? And my denominator remains as it is now. Now I know that square of a square root is nothing but the term itself, right? So the first part becomes n square minus n minus 1. I'm referring to the numerator. And for the second part, n alpha plus beta the whole square, we apply a plus b the whole square formula, which is nothing but a square plus b square plus 2ab, right? So let's expand the numerator and see what we get. So when I expand the numerator, I know that the first part of the term becomes n square minus n minus 1, right? And let me highlight it in, say, a different color, say green. And then the second part, when I apply a plus b the whole square formula on n alpha plus beta the whole square, I get n square alpha square plus beta square plus 2n alpha beta. And remember, folks, we have a negative sign, and therefore the second part of the expression in the numerator becomes a minus n square alpha square minus beta square minus 2n alpha beta, right? So this is what I have in the numerator. Now all that I'm going to do next is I'm going to combine the n square terms, I'm going to combine the n terms, and I'm going to combine the constant terms in the numerator. So we will have to do a little bit of jugglery with respect to the numerator. So let's rearrange these terms, combine the coefficients of n square, combine those of n, and then finally your constants, right? So once I do the rearrangement, take a closer look at what we have in the numerator, right? The coefficient of n square is 1 minus alpha square. The coefficient of n is 1 plus 2 alpha beta. And then I have a minus beta square minus 1, right? So that's what I have in my numerator. And I think I can also bracket this, right? I can write my numerator, the constant portion of the numerator, as minus of beta square plus 1, right? So this is what I have. What we've been given is this particular term, right, has got a finite limit, right? Which is nothing but your zero, right? Just drawing your attention back to the question where we've been given that the limit to this particular expression is zero, right? So I want you folks to think through this for a minute. Now imagine for this particular expression, when will it have a finite limit, right? Let's assume I multiply and divide the denominator by an n, right? And what happens when I do that? I'm going to write that in the next step. I pull out a n, which means that I need to divide this entire expression by a n, right? I hope you folks are with me, right? So what happens now is my limit n tends to infinity. This n, right, I take it inside the square root term. And when I take it inside the square root term, what happens is I will have to rewrite this as square root of n square minus n minus 1 divided by n square. And similarly, when I take this n and divide n alpha plus beta by n, I get an alpha plus beta by n, right? So this is what we get once I take the n square inside the square root, and which is what you see in the denominator right now. What I've done is my n is nothing but square root of n square. So what I get in the first part of the denominator is square root of n square minus n minus 1, the whole divided by n square. And then the second part is n alpha plus beta, the whole divided by n, which becomes an alpha plus beta by n, right? Which is again highlighted in green. Now, what we have been given is this particular expression has got a finite limit. So, as next steps, what do we do? Now, for this particular expression to have a finite limit, my denominator should be a finite number, right? It cannot take the value 0. So, let's examine the denominator before we come to the numerator in this particular expression, right? So what I'm going to do is I'm going to further decompose the term inside the square root in the denominator, right? So the first part of the term becomes a 1. The second part of the term is an n by n square, becomes a 1 by n. And the third part is minus 1 by n square, right? So now let's take a look at uh, what happens when n tends to infinity, right? You see the denominator, you see that the term inside the square root tends to a finite value, which is 1, and the term in the second part of the denominator, which is alpha plus beta by n, tends to alpha, right? Now that's with respect to the denominator. Now with respect to the numerator, I know that I can connect this n here, right? And I'm just highlighting that in turquoise for you folks with the n square and n terms in the numerator, right? And when I do that, all that I will get is, let's do that in the next step. Now what I'm going to do is the n which you see highlighted in turquoise, I'm going to divide the entire numerator with that particular n, right? And what happens is now I'm going to be representing my numerator in the x by y format, right? Which means my first part of the expression becomes n square by n times a 1 minus alpha square. And then I come to my second part, I have a minus of n by n times 1 plus 2 alpha beta. And then I come to the third part, which is nothing but a minus of beta square plus 1 by n, right? So now, and all of this divided by the term which exists in the denominator, right? Remember that n in the denominator highlighted in turquoise has moved to the numerator now, right? Now, I know that my term in the denominator tends to a value 1 minus alpha, and then I have a term in the numerator. And if this particular entire expression is to take a finite value 0 as its limit, what are those conditions that needs to be fulfilled is what we are going to do next, right? So take a look at this. My n square by n here becomes n. Okay, let me highlight it in turquoise. My n by n here becomes a 1, and this term as n tends to infinity will tend to a 0, so I don't think we will have to worry too much about it. So let's go to the next line, and what happens now is I'm going to rewrite this term. These simplifications what we just now spoke about. So my numerator becomes n times 1 minus alpha square. Okay, that's my first part of the numerator. And then I come to the second part. It becomes minus of, I know that my n gets cancelled, so I have a 1 plus 2 times alpha beta. And then my third part, I cannot do anything much here, so I leave it as it is, as a beta square plus 1 divided by n, right? And remember that we still have our denominator, so let's just copy this denominator as it is before we move to the next step. So now I'm going to spend a few minutes here. Now, the way we go about solving this problem is, I notice that as n tends to infinity, my denominator tends to 1 minus alpha, right? Because the term inside the square root becomes a 1. And then alpha plus beta by n, which is highlighted in green, becomes an alpha, right? So I know that my term in the denominator is going to be a 1 minus alpha, and my term in the numerator is n times 1 minus alpha square minus of 1 plus 2 alpha beta minus beta square plus 1 divided by n, right? So as n tends to infinity, for me to have the numerator take a finite value, this term n times 1 minus alpha square should not exist, right? Because what will happen is, if it does not exist, then my 1 plus 2 alpha beta is a constant, okay? And then my beta square plus 1 divided by n will also tend to 0, right? So for me not to have this turquoise colored term, what is that condition that needs to be fulfilled, right? That's pretty simple, right? 1 minus alpha square equals 0, right? I hope you folks are with me. And when 1 minus alpha square equals 0, what is my alpha? My alpha equals plus or minus 1, right? So now when alpha equals plus or minus 1, you'll have to remember that your denominator is 1 minus alpha as n tends to infinity. So let's work this out, assuming that your 1 minus alpha square is 0, right? So what happens is, when your 1 minus alpha square is 0, then your expression will tend to a finite limit. Otherwise, you will never be able to arrive at a finite limit. And what you're being given is, this has got a finite limit with a value 0, right? So what happens to this particular expression is, let me copy this entire thing as it is, right? And assuming that under the condition 1 minus alpha square equals 0, what will be the final limit of this particular expression, right? So let's write that down. So what happens is, my 1 minus alpha square, I don't have to worry about whether alpha is equal to plus 1 or minus 1, okay, in the numerator. So what will happen is my numerator will be just left with one single term, 1 plus 2 alpha beta, right? Of course, minus of 1 plus 2 alpha beta, right? Because the beta square plus 1 divided by n term also tends to 0, right? And remember, we are working under the condition that alpha equals plus or minus 1, right? And now let's come to the denominator, which is where this is going to help you understand whether alpha equal to plus 1 or minus 1, right? So my first part is a 1 under the condition as n tends to infinity. And my second part, which is alpha plus beta by n, ends up becoming just an alpha, right? Now, if this particular expression, right, minus of 1 plus 2 alpha beta divided by 1 minus alpha, if this is going to be the limit, right, and we've been given the limit in the question itself that this particular limit is 0, then I can confidently say that my 1 minus alpha cannot be equal to 0, because then uh, your limit cannot be a finite one, right? Because the denominator is taking the value 0 then, right? So what it means is 1 minus alpha can never be equal to 0, which means my alpha can never be equal to 1. So I hope you folks are with me. So now I know what is the only value that alpha can take, which means that my alpha can take a value which is minus 1. So when alpha takes minus 1, I know that my denominator here becomes 1 minus alpha, which is 1 minus minus 1, which is a 2, right? Which means my numerator, which is minus of 1 plus 2 alpha beta, has to be 0, right? So let's write that down. As well. So 1 plus 2 alpha beta becomes equal to a 0. So what does it mean? My alpha is equal to minus 1, which means that my 1 minus 2 beta, all that I'm doing is substituting my alpha equals minus 1 equals 0, which means my beta equals half, right? So I found out alpha and beta. My alpha is minus 1, my beta is half, right? Therefore, my 8 times alpha plus beta, which is what we've been asked to figure out in the question, is nothing but 8 times alpha plus beta, which is minus 1 plus half, which becomes a minus 1 by 2. So, which means 8 times minus 1 by 2, which is a minus 4. And folks, if you think this problem can be solved in a much better way, in an easier way, please do highlight in the comments. I'm happy to discuss method 2 with all of you. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.